Hi, I'm Gabriel, and I'm going to show you how to do some stuff in Unity. I'm going to start out by showing some prototyping for our game, focusing mainly on Unity and less on C#. Okay, so I'm going to try to prototype driving today, which means my first goal is to make something move. Now, our 3D modeler, Adam, hasn't made a car yet. That takes a lot of time, and he'll be covering it in a later video anyway. For now, I'm going to do something called gray box prototyping. That's when you use gray boxes instead of actual art. This is very useful because it means that as a programmer, you won't have to wait for your artists to finish whatever they're working on so that you can get to work. So I can start programming a car before I have a car to program. So that means it'll look ugly, but we're just focusing on the mechanics, so that's okay. So let's start out by creating a plane to be the ground. I'm going to make it decently large. Okay, very large. It's actually gigantic. Maybe a little smaller. Reasonably large plane. And put it at the origin. There we go. And it's going to be hard to tell if you're moving on this plane since it's all just white. If you look at the game view, there aren't any landmarks or anything. So I'm going to add a material to it, but it's not going to be the final material. So I grabbed a prototype materials pack for free off the asset store. The asset store is a great place to grab some stuff for free if you want to start prototyping a game. So here are the options for materials. Let's go with soil. Sure. So it doesn't look very good, but whatever. At least there are landmarks and you can tell that you're moving when you're moving, which is kind of important if you're programming something to move. So remember, our first goal is to make something move, so I'm going to make a car. Now, it's actually just an empty that I'm going to call car, but we'll get there. I'll add a rigid body to it, which is the part that tells Unity that you'd like it to move. Give it a fairly large mass, 1,500 kilograms, because cars are heavy. And a collider. Now I'm going to create the collider as a child because I want to separate it from the car, allow me to rotate it and position it separate from the origin of the car. So this will be the body of the car. I'm actually going to make the body of the car out of 2 colliders. So I'm going to add a cube and another cube. The first cube will be the chassis, and the second one will be the cabin, just roughly. Again, this will all be replaced by art later, so it's not that important that it looks correct. So I'm going to make it thinner, move it up, make it longer, make it wider. Sure, good enough. And the cabin. A little shorter, a little wider, a little longer. Move it towards the back. So then we have a definite front for the hood and back. If I hit play, this should, cross your fingers, hit the ground. Thud. All's good. Well, we made something move. That's the first objective done. Just a quick show off here. It is indeed following physics, so it will rotate to the ground. There we go. That looks pretty realistic, right? So next up we need wheels, because a car is not a very good car without wheels. So let's add some wheels. For organization, I'm going to place them under an empty, which I'll call wheels. Now I need 4 wheels, so I'm just going to make 1 and then duplicate it a few times instead of doing all the work 4 times. So I'm going to make another empty, add a component, physics, wheel collider. There's a wheel, that green circle there. Let's make the front left first. Arbitrary, doesn't really matter which one you do first. Mass of the wheel, 20. Sure, radius of the wheel, 0.5. That's pretty big, but we're thinking like a dune buggy, so giant wheels would actually be okay. Damping weight is okay. Suspension distance, let's make it bounce a little bit farther, 40 centimeters instead of 30. And the target position of the suspension I will lower to 0.2. This will give more distance that it can bounce up if it hits a bump. The rest of the numbers should be okay to start out with, but they're definitely something that I'll look at tweaking later. Let's give it a better name than GameObject. Let's go with front right wheel. In addition to just the wheel collider, we need something to see as well, because you'll notice in the game scene it doesn't actually have any wheels, even though in the scene it does have a wheel. That's because this is simply a physics object and not a graphics object. So I will add a cylinder as a child. Remove the cylinder's collider because the wheel collider already takes care of that. Rotate it. Scale it down a bit. That looks good. Move it down somewhat into place. The exact positioning doesn't much matter because the vehicle script will take care of its actual placement. It is important to note that that Unity will not move the children of a wheel to follow it as it bounces. So that has to be done from a script. I've already written that part. You can look over it later. I'll post it on GitHub later. And you should get to it through a link in the description. So there's one wheel done. Duplicate it. Let's make a back wheel. Duplicate both of those. Invert the X coordinate. Now we have 4 wheels. Let's give them better names since they're not all front right wheels. This is the back right. So now it should bounce a bit when it hits the ground because of the wheel suspension. Bit of bounce. Now you'll notice when it falls that the cylinders on the wheels do not move because, again, that's just the graphics, not the physics. Also, it should roll. So if we tilt this plane just a bit, it should roll down the slope. There it goes. So the wheels work. That's good. Next up, we need to make the car work, because a car does more than just roll down a hill in neutral. So I've already written the script for the car, which you can look at, like I said. I'm not going to go through all of it in this video because this is not a programming video. So now, when I hit play, I should be able to manually adjust values for the throttle and the steering, and the wheels should turn as they should. So as I change the steer target, you'll notice the front wheels rotate, which is good. And when I change throttle, it should drive. And there we go, it drives. But it doesn't make a very fun game if you need to open it in Unity Editor and change these values by hand. So I have another script for the driver of the car. Now all that this script does is it takes your WSAD or arrow key presses and changes them into inputs in the car script. There's only one thing that you need to change to make it work, and that is under Edit, Project Settings, Input, and change the jump axis to be called handbrake, because you're not jumping, you're hitting the brakes. That's a good enough quick fix to get this thing going. So now when you hit play, I can drive the car around without needing to change the values. But there's still something pretty big missing, and that's the camera. The camera needs to move to follow the car. So we need another script to tell the camera to move to follow the car. I've prepared one here, an empty script which I'll run through writing, but first it's good to set up the scene to make the programming easier. So I'm going to make an empty that will be the camera arm. The camera arm will sit at the position of the vehicle. And the camera is a child of that camera arm, so that wherever the camera arm moves, the camera moves. Let's go higher. Car's not centered. Alright, camera should be higher, maybe a little farther back, and more importantly, it needs to tip down a bit. Maybe a little higher. So if the camera arm, wherever the camera arm moves in the scene, the camera will follow and will point at that position. Which is pretty convenient because it means that all that our program has to do is move the camera arm to the same position as the thing that it's trying to follow. So let's assign the script to the arm and then edit the script. So the only variable that we need to make this work is the thing for the camera to follow, which we'll call follow. Making it public makes it show up in the editor, so I'll make a public transform follow. When it starts, we'll move to the position and the rotation of the follow instantaneously. So this means that if the camera, if you decide to change where the vehicle starts, as soon as you hit play, the camera will move to its position and you won't be able to tell that the camera wasn't also there before. So let's change the transform dot position of the camera arm to equal the follows position. And then also change the transform dot rotation to equal the follows rotation. Let me zoom in a bit so you can read this. If you're watching it at anything lower than 1080, you probably can't read it. Then every frame, we want to do the same thing, but not quite. So the first thing that you want to change is instead of doing it every rendered frame, you want to do it every physics frame. So that means using the fixed update function instead. The car is moving once every physics frame, so we need to move the camera every physics frame as well, or else they won't move in sync and the camera will appear to jitter on screen. So if we run this, it will work, but it won't be a very nice looking camera. So we assign the follow to be the car, and we should be able to drive the car around, and the camera will move. But you'll notice any amount of jerking that the car does, the camera also gets, which is very jarring. And also the car never changes position on screen. It's always in the same spot. You can never see the side of the car or anything. If the car flips over, so does the camera. It's not a very good way to follow the car. So instead of following it strictly, we'll follow it loosely. So instead of moving exactly to the position of the follow, what if we just move a certain percentage of the way? I'm going to make a new variable. Let's go 10% of the way. I'm going to use a function, a vector function, called lerping. vector3.lerp. Lerp means linear interpolation. I'm going to make a line, that's the linear part, from transform.position to the follows position. Then I'm going to choose a spot on that line 10% of the way there, which is what the strength variable is for. So if I want to change that percentage, I just change the strength variable. I can do the same thing for rotation, but rotation is not stored as a vector3, so instead I need to use the quaternion class. So quaternion.lerp, I will set up the same sort of thing. This is harder to visualize, but if we go from one rotation, our current rotation, to the follows rotation, but we don't go all the way there, we just go a certain percentage of the way there, we'll achieve a similar effect. So now, if I hit play, the camera will not strictly follow the vehicle. You'll notice you can see a bit of the sides of the vehicle as it turns, and even when the vehicle bounces around, the camera does not bounce the same way. So it's not strictly locked anymore. This is even easier to see in the scene view. If I just grab the car and move it around, you can watch the camera follows like a rubber band. I can change the strength. If we make it lower, say 1% instead of 10%, it will follow more loosely, kind of lazily moves into position. If I change it to a larger number, 30% maybe, it will be very snappy when it moves into place. If you change it to a 1, it'll be locked like before. If you change it to a 0, it won't move at all, regardless of the follow's position. I'm going to keep it at 0.1 for now, but that's definitely the sort of thing that should be tweaked later, depending on how your playtesters like it. This car really likes to fall over. Quick solution, we can just make the wheels a little farther apart. There are definitely better ways to do this. How about that? Hey, that's pretty good. So I didn't really change anything. I just switched some numbers around and it works now. I'm sure there's a deep underlying reason for that, but it works now, so whatever. So camera's done, car's done, but not quite actually. You see, I've been talking to Adam quite a bit, and I think we've decided that there's a pretty good chance that our game will take place on a sphere. So how can we make a car that works on a plane work on a sphere? So the only real issue to contend with here is gravity. There are a few different ways that we can make the car try to move towards the center of the sphere. We could rotate the sphere as the car drives so that down is always towards the center. But this has some drawbacks. For example, the physics engine doesn't like moving colliders. So if you tried to rotate the sphere to keep the car on top, that means you're rotating everything in your world except for the car, which could introduce some lag. Also, no other objects will behave correctly. So let's say you have a crate that you can drive into and hit it rolling across the surface. If it were on the other side of the sphere, it would be on the bottom and it would fall off, which isn't what you want. You're also limited to real-time lighting because static baked lighting only works when the objects don't move. And if you're moving your entire world, then you can't use baked lighting. It also might be difficult to get the car to behave correctly if you're rotating the entire world, because the wheels aren't designed with that in mind. So let's not rotate the entire sphere. Let me make a sphere first as I'm talking. Another option is to change gravity all the time so that depending on where the car is, gravity is always changed so that it's pointing towards the center. So if you're on the side of the sphere, gravity will point sideways to bring you back. If you're on the bottom of the sphere, it'll point upside down to bring you up. This has a similar drawback to the first one, that you're limited to only one moving object, one object that follows gravity. There are workarounds to that, of course, so it's only an issue of being kind of a pain. And the last way is to turn off gravity completely and to apply your own custom force towards the center. Now this is nice because you can just apply your gravity script to anything that you want to move, and they'll all move towards the center of the sphere, and everything will be great. The problem is the PhysX wheel colliders only like to work when gravity is pushing them against the ground. If you use a custom force, they don't grip the right way. So I'm actually going to go with the second option and change gravity every frame. That is limiting. It does have its drawbacks, but again, this is just a prototype, so for the final, I'll probably come up with a more elegant solution, but for now, it's good enough. So how do we make the car move towards the center? Wait, pick a better ground material. Let's go with that one. To make the car move towards the center, we actually only need to add one line to the vehicle controller script. So we open the car. Every frame in fixed update, let's do something else. We will change gravity to point towards the origin. So we want to change physics.gravity. Physics.gravity should instead equal our position normalized. So if you picture a line from the center of the scene to the car, gravity should point along that line. Normalizing the position cuts it to a length of 1, because we don't want the gravity to get stronger the farther away you are from the center. That doesn't make any sense. So we'll cut it to be a length of 1, so no matter how far away you are, it's always the same. And then multiply it by 9.8, which is the acceleration due to gravity in meters per second squared. And we want it to point in instead of out, so we'll make it negative 9.8. That should be all it takes to get it to drive on a sphere. The camera should follow it just like before, no problems there. Although with a more complicated camera following script, it might be an issue. So you see as I go around to the bottom of the sphere, the camera continues to follow the car, and the car continues to stick to the surface. Steering still works. Still really drifty. How much the vehicle likes to drift is a problem of wheel friction, which you can look up yourself on the manual page for wheels. I have a lot of good information on wheels on the manual page, including wheel friction curves. There are a lot of numbers that go into defining how the wheels slide. So if you want your vehicle to be more or less likely to fishtail, those are the numbers to change. So that's about it. There's a car. It drives. It drives based on the keys that the user presses, so that's good. There's a camera. It follows the car. It's nice to be able to see what you're doing. And the car can even drive on a sphere, which is going to be important for later. So I think this is a pretty good demonstration of a game mechanic that I can then send off to my other team members. So I can send this to Adam and say, hey, what do you think? And he'll give me feedback on how he likes or doesn't like how the car drifts or how it accelerates or those sorts of things, so I could start making changes this early in the game development season so that towards the end we have a very nice system to have a car drive around. So there we go, prototyping game mechanics. Next week, join Adam. He'll be talking about using Blender to make terrains, even spherical terrains, so that I'll have some actual assets to put in this and start working towards an actual game instead of just prototypes. So I guess you'll see him then. Thanks for watching. See you next time.